Hi, how are you guys doing today? I like Meme Maker that you are deciding to do some cramming just before we actually get started. Oh, I just realised as well that the sound is coming out of one of my speakers, which is certainly not ideal. There you go, much better. Yeah, so is that something that you guys do? Do any of you like try and have a look at the topics first before I go over them, just to make sure you sort of know what we're talking about? Or is that just Meme Maker? Hey, Raoul. Hey, Catherine. Hey, Shamima. Hey, Namrata. Hey, Freya. Oh, that's really cool. Yeah, I was looking the other day, and I've actually gone through quite a lot of this now, haven't I? So I was trying to work out roughly how much of it I've actually gone over, and I don't know, it's a good old chunk of year 12 that we've managed to kind of get through. So I'm really happy that we sort of managed to ensure we haven't forgotten everything, you know? Oh, so has anyone been doing anything interesting recently? Where's the cap? The cap is currently sat in another room. I did like blow dry my hair today, so it was sort of staying up for a bit, but it's my hair's really thick, so it sort of just plops down again. So can't bother to get a cap. Watching test card with CFAX. What is it with you and CFAX? I've honestly never heard someone talk about CFAX as much as you, me maker. Shooting from your pie and drinking red wine. Hmm. That actually sounds quite nice. The latter half. Eating, nice. I'm terrified to actually go on the scales at any point soon. I feel like I need to make sure that, I don't know, the gym has to open before I can go back on the scales, I think. Baking. These classes at 3 o'clock. The classes at 3 o'clock are the reason you wake up at a decent time. I hate to think what time you'd be waking up if you weren't doing this. Naomi, I will get back to you in a second. That's a good question. What exam board is it? So every session I've ever done on YouTube ever has always had these two questions. Firstly, what exam board is it? Secondly, I'm sure someone's going to say it in a second. In fact, let's see if someone says it like legitimately before I've actually managed to yeah, get through this. It is me on my mug. Yeah, I'll show you that in a second as well. So exam boards, basically, I'm focusing on all the British ones. So AQA is the most popular one in the UK. OCR and EdXL-A are the second most popular in the UK, followed by EdXL-B. And I'm also doing some Cambridge International stuff because I've been learning their spec recently. So I'm going to cover that. The Welsh board, which is Educas or WJC, I've got a lot of that in there too. And to be honest, the focus is on the British ones, but there's an awful lot of I'm basically going to cover anyway. So it's going to be fairly relevant for most people. The only one I'd say that this actually isn't that great for today is EdXL-A, just because they don't go into much detail of hemoglobin. But otherwise, yeah, EdXL International, yeah. So no one asked the other question. Oh, there you go. Sard did ask it, but Sard, I see it wasn't legitimate. It's about 45 minutes to an hour. For those of you asking, yes, when I quit my old job, my colleagues thought it'd be funny to make a mug with my face on it multiple times. So there is me multiple times. That's me as Rosie the Riveter. That is my cat. And some kids at my old school, because my last name is Vaughan, thought it'd be very funny to turn my face into a corn on the cob. So that is me as a corn on the cob. Good times. Someone asked what good sort of careers you can get with a degree in biology. That is a good question. So I think with anything in science, right, you've got to think about if you want to sort of go into academia or if you want to go into something different. So for instance, if you wanted to do biology and you were pretty set on going into research, then you could stay in biology and do some research and do a PhD or a master's, and you could basically work in academia your entire life. So that is something that you could do. If you didn't want that, you can use biology as a way to get into a few graduate entry things, maybe medicine, maybe veterinary, maybe dentistry, whatever. You could use it like that. Or you can use it just to basically prove that you are clever. And in which case you can go into things like, I don't know, financial things. So I've got a few friends who have ended up working in finance because they wanted lots of money, and biology, if you go into academia, does not get you any money. Teaching is always a good one. any other branch of biology, like marine biology or something like that. Yeah, I think there's quite a lot of options, to be honest. How do you pronounce bilirubin? Like that. As soon as I came on, I saw the mark. Yeah, it is good mark. Can you get into neuroscience with a degree in biology? So most universities, if you are interested in like a specific bit of biology, I'd say you're probably better off doing a degree like biomedicine or biology or whatever, and you sort of specialize as you go through. So my university, my first university, which was Southampton, basically you got given a certain amount of freedom with what you got to do. So I did probably about 2 neuroscience modules. Had I wanted to, I probably could have done, I don't know, maybe 6 or 7. So it depends what you do. I went to UCL for my second, for my postgraduate stuff. So UCL was my second one. Southampton was my first one. Anyway, right, let's get cracking though, eh? So we're going to look at hemoglobin today, and I thought this was a good one. Some people were like saying, oh, this isn't very big. Why spend so much time on it? People commonly ask me about hemoglobin. So let's have a look. Biochemistry is cool if you're really into biochemistry, yeah? Thank you, guys. And as always, because I always have one of these things, at the end, I've got a free account that I can give someone. If you want that, you have to tag us on Instagram and you have to share like a great picture of you having a great time sitting watching this session. So if you want to do this, I don't think many people have done it so far this week. So if you want to have probably like a 1 in 10 chance of getting 200 quid worth of free education, then you should follow us on Instagram and then you should tag us, put us in your story or whatever, and then yeah, you might be able to get a free account. Like, why not? What are you gonna lose? Also, I'll have a coupon at the end if you want to have £10 off. Okay, how often do you do the free account? Yeah, I'm doing it every week at the moment. Is the free account guaranteed? What, for one person? Yes, there is a chance that one of you will get a free account. So I have one student who has been coming to pretty much every lesson of mine that I've done since then. And yeah. Anyway, so starting off then, and I probably should mention that some specifications are more into carbon dioxide than the others. So some of these you're going to see and you're going to be like, oh my God, I had no idea carbon dioxide was this important. It might not be. So OCR, absolutely love it. I think Cambridge International, absolutely love it. AQA, they're not that bothered about it. So some specs, if this looks really confusing, it might be because it's just not in your spec very much. But I've tried to make sure that I've covered most of it. So carbon dioxide release during respiration can affect the percentage oxygen saturation of hemoglobin. The tertiary structure of hemoglobin is affected when carbon dioxide reacts with water to form carbonic acid. The reaction releases hydrogen ions. Which of the statements A to D explains this change? So the release of hydrogen ions causes the pH to rise, reducing hemoglobin's affinity. The release of hydrogen causes the pH to rise, which increases its affinity. pH to fall, which will increase affinity, or pH to fall, which will reduce hemoglobin's affinity. Oh, you guys can't see a question. God, I'm an idiot, aren't I? I love that I've just been looking at you. You got me here. Bye. Bam. I am a professional and I know what I'm doing, so thank you for that. There you go. You should be able to see the questions now. Is a free account just for biology? Yes. There you go. Right, that was the first thing I was going to show you, and then actual question. There you go. See, look, I was even circling things and everything. You guys just never saw it. So, go on. How does carbon dioxide affect hemoglobin? Is essentially what we're saying here. So, what do you guys think? I did forget to share the screen. I normally do it the other way around. I normally tend to be good at sharing the screen and forget to actually put my face up for any seconds. This was in your test today. That's convenient. Toby BN, I'd expect you to get this absolutely right then. So 3 people have answered so far. Okay, a couple more. You guys are very quiet. K Muller, be careful here because you're saying carbon dioxide affects affinity, but all of these are suggesting that, right? Okay, so the release of hydrogen ions. So you should all know what it does to pH. So hydrogen ions are going to lower the pH. So it cannot be that one. It cannot be that one. It's got to be one of these two. So what is carbon dioxide going to do? Or think about where you're going to get carbon dioxide. You're going to get loads of it in respiring tissues. And if you've got carbon dioxide in your tissues, you're hopefully going to be getting rid of oxygen from hemoglobin so it can move into your tissues so they can respire. So carbon dioxide is there to reduce hemoglobin's affinity. So correct. You guys are right to say D. It is definitely D. Why is it talking about pH? So as I said earlier, some specs are more into carbon dioxide than others. Essentially what's going on is CO2 reacts with something called H2O, as I'm sure you are aware of. There's an enzyme that some of you might be aware of. If you know the enzyme, feel free to shout it out. And you make H2CO3, which is called carbonic acid. H2CO3 is basically going to be in a little reaction where it's going to dissociate, forming H plus and HCO3 minus. Essentially, H plus is what acids are. Carbonic anhydrase, well done. Yeah, OCR really like this topic. Okay, so hemoglobin transports oxygen around the body of many animals. Hemoglobin is a protein with a quaternary structure. What is the meaning of a quaternary structure? Why does it reduce affinity? Because it wants to get rid of oxygen. It wants to offload oxygen, unload oxygen. Yeah, so that the oxygen can go to the tissues. Very good, Sard. So 2 or more polypeptide chains, so more than one. Non-protein, I think you meant, non-protein prosthetic group. Does AQA need to know? AQA needs to have the understanding that CO2 causes an acid to be made, but it doesn't need to know much details. Groups of chains, prosthetic groups. Depends what EdXL you're doing, Raoul. Final 3D structure, that's a tertiary structure. Okay, so good. You guys have all said quite a few things. So Raoul, it's not EdXLA would expect you to know this answer, but this is pretty much the depth of how much you need to know about hemoglobin. So for 1 mark, you have numerous things that you could say. So you could say that there is more than one polypeptide chain. Whoops. Right, as I'm sure lots of you know, there are alpha and there are beta. So we got alpha and we got beta chains. And also there are prosthetic groups. So some specs refer to these as different things. So some of them call them non-protein groups, some of them call them prosthetic groups, and some of them call them conjugated proteins. I don't really care which one you go for, whatever one your spec says. What's the one in hemoglobin called? Heme. Good. If you ever get stuck spelling it, A comes first. Let's think about it alphabetically or something. A comes first. If you're American, they spell it like that. Lovely. So there's heme in it, which is a non-protein group. Very good. So the following events, this is, I think, one of the final weird ones, which is going to be like OCR, EdXLB, and EdXL International, whatever. So the following events occur when carbon dioxide enters an erythrocyte into a capillary. So an erythrocyte is just a red blood cell, in case you don't know. So hydrogen carbonate ions diffuse into the plasma from the erythrocyte, dissociation of carbonic acid, carbon dioxide reacts with water forming carbonic acid, chloride ions diffuse into the erythrocyte from plasma. So think logically about what's going to happen. Even if you've never done this before, I reckon you should be able to actually get this right. So here's a little red blood cell. Carbon dioxide, it said, has entered my erythrocyte. What's going to happen first? No, AQA wouldn't want you to know this, but I would expect I would have probably shown a question like this to an AQA student just to see if they could get it right. So you don't need to know the details of it, but you should be able to work out a logical order. But no, AQA strictly could never give you this question. So CO2 is going to move in. Lots of you are actually getting this right. So CO2 is going to move in. As soon as it moves in, it is going to react with water. So inside, I've got my CO2 plus H2O. Okay, so I'm going to make acid, which is H2CO3. As soon as you make an acid, acids are going to dissociate into H plus HCO3. So that one's going to be first. That'll happen second. So I think we've already worked it out, but it can be B. That's the only one it can be. There's only two of them that start with carbon dioxide reactive water. So it's got to be this one. In terms of the other things that happen, the hydrocarbon ions diffuse into the plasma. So this is going to move into the plasma. And then because I've got this hydrogen ion inside, you get something called chloride shift happening, where chloride's going to move in to try and balance this sort of imbalance in charge. That, for those of you who do OCR, is called the hamburger phenomenon, which is my favorite thing in biology, I think. So chloride shift is also called the hamburger phenomenon. Good term. Yeah, and some of you will know that hydrogen needs to sort of bind with hemoglobin here as well, forming hemoglobinic acid. Very nice. Okay, right. Let's move into something which everyone does then. So erythrocytes are full of hemoglobin. Describe the role of hemoglobin in transporting oxygen around the body. So what is the role of hemoglobin in transporting oxygen around the body? Wow. Yeah, probably. Google hamburger phenomenon. It will come up with chloride shift. So it forms oxyhemoglobin in a reversible reaction as hemoglobin has 4 heme groups and can carry 4 molecules of oxygen. After binding the first molecule, it changes shape. Okay. Binds with oxygen to form oxyhemoglobin. Each has 4 molecules at high partial pressure of oxygen and releases them when the partial pressure is low. So it binds with oxygen to transport as much as possible, extracts oxygen and binds with it to create oxyhemoglobin, which has 4 molecules of oxygen. Okay, I would say that we're probably averaging about 2 marks here. So the role, like, what's it actually doing? Do you reckon it's relevant that it's got 4 binding sites? To this question, is that particularly relevant? So describe the role of hemoglobin in transport oxygen. Like, maybe it's a bit of one of those details where I guess you'd probably write it because why not? But it's not the most relevant of things. You guys are definitely right to say that hemoglobin is going to bind to oxygen. So in case you haven't seen it, HB is quite commonly used as like a symbol for hemoglobin, and I'm going to use that because I'm lazy. So hemoglobin binds to oxygen, and yeah, you guys are right. So you'll get 4 times O2 molecules because there are 4 times heme groups. Is it changing shape? Is that relevant to this question? Yeah, I don't know if it is. So I think if you started to, those of you that know this graph, where you've got this sigmoidal shaped graph, I think if you started talking about how it's difficult for the first one to bind, and then it's easier for the second and third, and then it's difficult for the fourth. If you started getting into that, you're not really talking about the role anymore. You're talking about the shape of this graph. So I wouldn't say that would be relevant. Maybe it would be okay to say that the first oxygen struggles a bit, but I don't think it's that necessary. So hemoglobin binds to oxygen. Where does it do that? And why does that happen? For this bit, you don't need to say about there being an ion. Good. So hemoglobin binds to oxygen. And we can say that this occurs in the lungs. Well, I guess it doesn't really happen in the lungs, as it happens just outside. So it occurs in, I don't know, capillary beds outside of the lungs. Why does it happen there? Good. Right. So another little term I'm going to start using. So you'll see when you talk about hemoglobin, you'll see partial pressure is used pretty much synonymously with how you would normally use concentration, right? So this is pretty much the same as concentration. Now, I'm sure there is someone out there, like a chemist, who will correct me at some point and say, no, it's not. I think you'll find that partial pressure is about a gas. And yes, it is true that it is about a gas. And in terms of this, well, actually, for the sake of this, I'm just going to use it pretty much interchangeably with concentration, but partial pressure is the right word to use, right? Essentially, if you've got a canister and you were to put a load of oxygen in it, right? If you had 3 particles of oxygen in it, the partial pressure is going to be low. If you suddenly put like, I don't know why I got rid of them. If you put loads in, the partial pressure is now going to be much higher. So if I were to draw a graph of partial pressure against concentration, they're basically going to go up together, right? You're going to get a, what's the word for that? The word has just gone from my head. So I have a little fish, proportional, that's it. You could say that they're proportional to one another. So it occurs in the capillary beds outside the lungs. And instead of saying partial pressure, the little like easy way of showing it is just PO2. Okay, so it occurs in capillary beds outside of the lungs when PO2 is high. Okay, so that is the role of hemoglobin. It binds to oxygen, and this occurs in the capillary beds outside of the lungs when oxygen or partial pressure of oxygen is high. Okay, someone said, and we can get a mark for this, that this will form oxyhemoglobin. What is the other important role of hemoglobin? And I guess we could also say that this is called either loading, or we could say it's called oxygen association. So partial pressure of carbon dioxide does have an effect. That's not what I'm getting at here. I will tell you what the words are in a second. Good. So in terms of the role of hemoglobin, right? The role is it can bind to oxygen when there is a high partial pressure of oxygen, and it can then sort of debind, that's not the word. It can unbind from it, and it can unload or it can dissociate from it when the partial pressure is low. Right, that is its role. Its role is to move it. Its role is to bind, move it around, which is because it's soluble, and then it will unload it when there is a low partial pressure. So it will unload when PO2 is low in respiring tissues. Okay, so the keywords that I've got written down then in my mark scheme for 3 marks are: first word, binds to oxygen. Easy. Second one is loading is the key word that you want to be using, or associating, which is the same, but you need to say when it happens. So loading / associating at high partial pressures of oxygen. Okay, so you didn't need to say it was in the lung, but you did need to say that it was at a high partial pressure of oxygen. So first mark. Second mark. Oxyhemoglobin will get you a mark, and then unloading is the final thing. Unloading of oxygen at low partial pressure, and you didn't need to say respiring tissues. Okay, so that is its role, right? Its role isn't about how easy it is to bind. Its role isn't about like much else apart from loading, unloading, and the bit in between where it sort of travels in the blood. So you could feasibly, and it wasn't a mark on this, but you might want to say that hemoglobin is soluble because it's globular, so it can dissolve in the blood and it can be transported. Hemoglobin does transport CO2, but very, very little. So some carbon binds directly to hemoglobin, which is called carbaminohemoglobin, but it's only like, I think it's like 5% of the carbon dioxide is transported that way. Most of it is in the plasma, but not very much. Okay, so this is getting more into some specs as well. So another change occurring after birth, so I assumed there was a question earlier about birth, is that fetal hemoglobin is replaced with adult hemoglobin. State one difference between fetal hemoglobin and adult hemoglobin and give a reason why it is essential to the fetus. Now, if you haven't heard of fetal hemoglobin, which AQA hasn't, I'll show you a graph of what it looks like in comparison to adult. So that is adult. Fetal is this one. Okay, that should be all you need to be able to assess how it is different. So everyone should be able to work it out now. So if adult is like this, fetal is just to the left. So Y. No, myoglobin is different. Myoglobin it's like a store of oxygen. If you ever wondered why meat is sometimes red or sometimes white, it's because of the presence of myoglobin and fast and slow twitch muscles. So fetal hemoglobin has a higher affinity for oxygen, so it can get more from the placenta. Very, very good. Has a higher affinity for O2, so it can get as much as possible. What does affinity mean? That is a very good question. I'll answer that in a second. Yeah, good. So essentially, when we talk about different hemoglobins, so my hemoglobin is different to some of yours. Like you might have some weird adaptations that make you better at doing something than I am. My hemoglobin is different to a child's or a fetus's. My hemoglobin is different to an alpaca's. We all have slightly different hemoglobins, right? So if you are a fetus, which is like the thing that happens after an embryo, one big difference is that a fetus has hemoglobin with a greater affinity for oxygen. So on this graph, I've got partial pressure of oxygen at the bottom, and I've got saturation of oxygen on the side. Now, if I look at one particular place, so I'm going to draw one line. Let's change the color of it to make it stand out a bit better. I'm going to draw one line on my partial pressure axis. There you go. So if I have a look, my adult at a partial pressure of, I don't know, let's say this is a partial pressure of 2, right? Arbitrary unit of 2. If I follow it across for the adult is not very saturated with hemoglobin. Maybe that's like a saturation of 10%. So not a lot of oxygen is bound. The fetus, on the other hand, its saturation is much, much greater. So its saturation is probably close to about 70%. So essentially, this term affinity is kind of an indication of how sticky hemoglobin is. It's sort of how readily it's going to be accepting oxygen into it. So a fetus at the same partial pressure as an adult will have a lot more oxygen bound to hemoglobin. The reason for that is because the placenta, which is where a fetus gets its oxygen from, has much less oxygen because it's the oxygen that's already, it's supplying the mother, isn't it? So if it's supplying the mother, there's going to be less there because obviously the mother's going to be using some of it. So the affinity needs to be greater than an adult's in order so that the fetus can have enough oxygen to survive. So the difference is, has hemoglobin with a greater affinity for oxygen because the placenta has a lower partial pressure for oxygen, right? In an exam, don't write PO2. Make sure you've written partial pressure first and then put it in brackets. So another difference you could have said here as well is the reason that fetal hemoglobin is different is because instead of having beta subunits like our hemoglobin has, it has something called a gamma subunit instead, which basically has a greater affinity. So what are you asking? Yeah, so y-axis, this is saturation. So how much oxygen has bound to hemoglobin, and PO2 is partial pressure. Yeah, partial pressure, basically think concentration, right? I want someone to correct me and tell me why that's not the case, because it basically is, but cool. Yep, Kang, you're all good. Should say percentage saturation of hemoglobin. Yeah, something like that. Saturation of hemoglobin, it would be a percent, and partial pressure would be, what is it? It's in pascals, is it? Like kilopascals, I believe. Wait, why does the placenta have a low PO2? Because lots of the oxygen is going to be going to the mother first, right? So if the mother has to supply blood to her brain, to her heart, to her digestive system, to her liver, then there's going to be less oxygen available for the child, right? You need to make sure there's enough oxygen for the child, but she also needs to survive herself. So there's just going to be less oxygen available. What does saturation mean again? So saturation is how much oxygen is stuck to hemoglobin. So if like one oxygen molecule is bound to hemoglobin, then it's 25% saturated. If 2 have, it's 50%. 3 have, it's 75%. If 4 have, it's 100%. Cool. Okay, so high concentrations of carbon dioxide in the blood reduce the amount of oxygen transported by hemoglobin. Name this effect and explain why it occurs. So a high concentration of CO2 in the blood reduces the amount of oxygen. What is this called? How does hemoglobin change as we grow older? It goes from fetal to adult hemoglobin. Oh, so someone just said in this graph, it shows that the fetus is more saturated. Exactly. So the fetus, if there is a low partial pressure of oxygen, right? So I know some of you are answering this, and you're right to say the Bohr effect. At a low partial pressure of oxygen, such as down here, look how saturated the fetus has. So its hemoglobin is so sticky, it has such a high affinity for oxygen that even at a low partial pressure, you end up having this much higher saturation, right? It might make sense if you look at it the other way around, actually. So if I were to draw one straight line on the other axis, so if I had, let's look at this saturation here, right? So for my fetus to be saturated, I only need a partial pressure of, say, 2 units. For my adult to be 70% saturated, I need it to have 3 units. So you need more oxygen to reach the same saturation level. Hopefully that makes sense. So yeah, those of you saying it, Bohr effect. So this is called the Bohr effect. Explain why it occurs. So high concentrations of CO2 in blood reduce the amount of oxygen. Name the effect and explain why it occurs. So why does it occur? Why does carbon dioxide lead to the release of oxygen? Causes a conformational change in hemoglobin. So it does change the hemoglobin shape because of hydrogen ions from a carbonic acid. So the affinity for oxygen is lowered. Very good. And decreasing pH blood plasma therefore has a lower affinity. CO2 makes pH lower. The hamburger effect. That's a chloride shift. Hydrogen causes it to become more acidic. O2 dissociates. I think it's dissociates as opposed to disassociates, just so you know. More CO2 produces more hydrogen ions, so more oxygen is released, occupies all the hem groups. Hamburger effect. Don't just say hamburger effect. Hamburger is it's a very specific thing where chloride moves into a red blood cell. I feel like I regret teaching you the hamburger effect. So I need 2 marks. So let's say, why does it occur? I think you guys have got this, to be honest. You are going to form carbonic acid. So CO2 will form carbonic acid. Even if you don't do a spec that talks about it, I'm sure you can remember that. So CO2 forms carbonic acid, which releases hydrogen ions. Okay, what could we use to describe this change in shape? Bohr effect, AQA does need to know about. So all specs need to know about the Bohr effect, apart from EdXLA. EdXLA basically don't need to know very much of still. Everyone needs to know the Bohr effect. Hamburger, ignore. Why is carbonic acid formed? Because basically the CO2 it doesn't dissolve. It reacts with water and it just forms carbonic acid. It's just it's like saying, why does hydrogen react with oxygen to make water? It just does. Conformational change. Oh, see, there's another term I was going for. It doesn't denature it. What's the word we use to talk about proteins a lot? Actually, I don't even know if I agree. So my mark scheme says tertiary structure, but it definitely has a quaternary structure. So I don't know if I'd say that. So CO2 forms carbonic acid, which releases hydrogen ions. Now, if you do OCR, you could say hydrogen ions bind to hemoglobin. In fact, hydrogen ions bind, forming hemoglobinic acid. Right? If you wanted to say that, you could. Right? Not everyone needs to say that, so I'm going to leave that up to you. Okay, but what you want to say is this changes or alters of hemoglobin. So you could say a conformational change. You could say change in quaternary structure, or you could say change in tertiary structure, according to my mark scheme, although I'd probably stick with quaternary structure. Carbaminohemoglobin is not really to do with this. So that's to do with when carbon dioxide binds directly to hemoglobin, which is pretty rare. Okay, so carbon dioxide forms carbonic acid, releases hydrogen ions. Hydrogen ions bind, forming hemoglobinic acid if you do OCR. This changes the shape of hemoglobin. Everyone should know this, right? And importantly, this is going to reduce hemoglobin's affinity for oxygen. Okay, so it's going to change the affinity. If you wanted another mark as well, it's going to cause oxygen dissociation or unloading. Okay, so you get a whole load of marks here, and basically I've made it a bit more complicated for those of you that do certain specs that make this more complicated. So the Bohr effect will get you a mark. If you can remember that CO2 reacts with water to form carbonic acid, you'll get a mark. If you don't remember that, but you remember that carbon dioxide basically acts as an acid, then maybe you'll remember that the acid changes the shape of hemoglobin, right? That's an easy one to remember. This reduces hemoglobin's affinity for oxygen, and this is going to cause unloading. Could you ask the equations? Of course I can, yeah. 4, 0, that means quaternary, which I can't remember how to spell. Might have a double T. I think it does have a double T. Yeah, so primary, secondary, tertiary. The equation is CO2 plus H2O goes H2CO3. H2CO3 is in an equilibrium. Whoops, so not like that at all. Where it forms hydrogen plus HCO3 minus. Bam. There you go, that's it. How do you know if it has a quaternary structure? Because it has more than one polypeptide chain. Cool. Right. Oh, so this is a good question, then. So this is one of these classic questions that comes up all the time. So figure 4.1 shows the oxygen dissociation curves for fetal hemoglobin and adult hemoglobin. Curve A represents fetal hemoglobin. Explain why the fetal hemoglobin curve is to the left. So in case you've ever seen this saying to the left or to the right, sounds like a Beyonce song. Essentially, if it's to the left, it means it's literally gone that way, right? If it's gone to the right, it would start in the same place, it ends in the same place, but in the middle, it's gone literally to the right. That's all it means, nothing more complicated. So in case this ever confused you, don't let it. So why is it to the left? Good. So I've always sort of said this in certain ways, and I saw some interesting ways to remember this. Actually, what was it? Yeah, so why is it to the left? Right, if you want a good way to remember some of these. So you can remember that left equals fetus. There's an E. Don't know. So if it's to the left, it has a higher affinity. So hemoglobin has a higher affinity for oxygen. Yeah, we want to say the reason why, so explain why. So we've said why, we're going through that. We want to say less partial pressure or lower partial pressure of oxygen in the placenta. And then if we're talking about it having a higher affinity, I like to talk about how you know it has a higher affinity. So I've always got my students to do this in the past, which I said earlier, which is where you draw one line at some random partial pressure. So let's go for 2.5, right? Here's my one line. I know it's got a lower affinity because look, in fact, it's got a higher affinity. I know it's got a higher affinity because at the same partial pressure, the saturation is like, I don't know, 25% more or so. So I would say something like that. So at the same partial pressure, fetal hemoglobin has a greater saturation. I'm going very slowly through these, aren't I? Has a greater saturation than adult hemoglobin. Okay, so the whole point of this then is you want to make sure that if you are a fetus, you want to make sure that you can still take up oxygen. So it has a higher affinity because there's a lower partial pressure in the oxygen. I know this because at the same partial pressure, fetal hemoglobin has a greater saturation. This allows, so I'm making this more complicated than I probably need to, allows O2 to be taken up at low PO2s. Okay, so the whole point of the fetus being to the left, right? The whole point of the fetus being on this side is if it was the adult, then let's say that and I don't know this, I'm making this up now, but let's say that the highest partial pressure that you can ever get in a placenta is, say, I don't know, 3, right? So about here. Let's say that's the best you can ever get in the placenta. If it was the adult, then the embryo would only, or the fetus, would only ever get to be saturated with about 60%. That might not be enough to survive. Whereas if it's on the left, then that number can go above 60% and probably up to about 80, right? So the whole point of this, and I guess this is the important thing to remember, it's to the left because this raises the affinity for hemoglobin, which means at low partial pressures, you can still have enough oxygen. Cool. So why, Kang, what are you not understanding here? So why do you want oxygen? Because you need to do aerobic respiration. The Vaughan Library. I like the sound of that. Yeah, no, the whole point of this is just to make sure that you have enough oxygen, right? So it has to be to the left because you need to increase the saturation at lower partial pressures. I'm going to ignore this one because it's only for OCR. So, yeah, sorry, I'm going to leave that one out. I've done loads of carbon dioxide ones. I want to show you some slightly harder other ones. So when hemoglobin in red blood cells travel through the capillaries of the lungs, it binds with oxygen to form oxyhemoglobin. When it reaches respiring tissues, it dissociates to release oxygen. Explain what causes oxyhemoglobin to dissociate readily in actively respiring tissues. So what is the main thing? What is the main thing that actually causes dissociation? So what is the main thing that actually causes dissociation? Partial pressure of what? Oxygen or carbon dioxide? Yes, everyone always gets confused with this. So carbon dioxide, I would always say, is secondary to oxygen. So in my curve, it looks like this, my sigmoidal shaped curve or my S-shaped curve, my saturation has the relationship with partial pressure of oxygen, doesn't it? So when I've got a very high partial pressure, it's very saturated. When I've got a very low partial pressure, it's not very saturated. So it's actually oxygen, which is the main thing driving the saturation. So what causes it to dissociate readily? It's actually mostly low partial pressures of oxygen, right? So low partial pressures of oxygen is going to be causing it to have to reduce its, or to dissociate. So low PO2 causes a low affinity, right? Most people think it's carbon dioxide, but it's oxygen. Okay, low partial pressure causes low affinity. This is going to cause unloading. Now, those of you saying carbon dioxide, you can also get a mark here for talking about carbon dioxide. So if you said CO2, or you could say if you wanted to, high partial pressure of CO2 will also cause unloading, or dissociation. And if you really wanted to make sure you got the mark, you could say this is called the Bohr effect. Cool. Yeah, some of you, Tellini, what are you doing for your syllabus? Just as an idea. Low affinity for what? Always, when we talk about affinity, I'm always talking about oxygen, never talking about carbon dioxide, because carbon dioxide doesn't really bind to hemoglobin very often. So why couldn't I do the last one like this? Explain what causes oxyhemoglobin to dissociate. This one, because about fetuses. That one, because it's just talking about carbon dioxide. This one is talking just about carbon dioxide. Okay, So low PO2 causes low affinity, that causes unloading. Carbon dioxide will also cause unloading. That's called the Bohr effect. So oxygen's affinity for hemoglobin. Okay, you're from Sri Lanka. Fair enough. If you're from Sri Lanka, I don't doubt for any seconds that you need to know this in less detail. Why does it never reach 100%? It's just unlikely to. Right, next. Let's have another go. This is a cool question. I like this one. As far as questions on this go, this is a good one. So figure 3.1 shows the dissociation curve of adult hemoglobin. So we're looking at different parts of the circulation. If the percentage saturation of hemoglobin is 98, what is the partial pressure going to be? Can you use a graph, basically? I love that you can get these questions because it means that you're guaranteed some marks. Even if you suck at biology, you can get some marks. Right, so 90, what are the little circles worth? 2, 4, 6, 8, 10. So they're worth 2 each. So 98 is going to be on here. So it's going to be the very top line. So it's this one here. That is one straight line. Cool. So it should be what are each of these little squares worth? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They're going to be 0.2, aren't they? 8, 10. Yep. So 12.2468. Okay. So it should be 12.8. Yeah. 12.8. So 2, 4, 6, 8. That should be pretty exact as well. Capillaries in the muscle tissue at rest. So if percentage saturation of hemoglobin is 70, what is the partial pressure going to be? So saturation of 70. So it's this line here. It's about there. 2, 4, 6, 8, 10. So 2, 4, 6, 8, 10 is exactly 5. Now, I know that you guys might not be able to see this as clearly as I can, but you need to be exact with these, so be careful. Capillaries in the muscle tissue during strenuous exercise. If partial pressure is 2, what should my percentage saturation be? 20%. Easy peasy. Very good. I don't think we've done one quite like this. In fact, no, I'm going to skip this one too. This one is similar to what we've done before. So essentially, explain how the structure aids the uptake of oxygen. You want to say that it's got heme groups that combine to oxygen, forming oxyhemoglobin. It has high affinity in certain places, low affinity in other places. And you could also get a mark talking about it being like, I don't know, that one's a bit of a stupid mark. You could also say that it's soluble and talk about that. So I'm going to skip that one too. Done that one. Let's have a look at this. So the graph shows the oxyhemoglobin dissociation curve for fetal hemoglobin and adult hemoglobin. Explain how the changes in the shape of hemoglobin result in the S-shaped oxyhemoglobin dissociation curve for HbA. There you go. We haven't had this one yet. So explain how the changes in the shape of hemoglobin result in this S-shaped dissociation curve. So why do I have this weird S shape? Kang, you are totally right. Why did I talk about carbonic acid in the one with the Bohr effect, but I didn't in the other one? I probably forgot about it. So yeah, I would always talk about carbonic acid and things with the Bohr effect. So this is called cooperative binding. Very good. Tell me more about cooperative binding. I like that some of you know this. So cooperative binding, what does that mean? First oxygen binds easily due to a high affinity, and then second and third are harder to bind. No, that is literally the opposite of what's happening. So if I have a look at HbA, then a change in partial pressure of 5 causes pretty much very little change in saturation. If I look at the next 5, comparatively, that gap is massive. So this is the first 5. So this is a change of partial pressure of 5, and it gets up to about 10. The next one, so that's a difference of 10. This one has a difference of 50. Right? So the first one struggles to bind. Saturated means how much oxygen is bound. The S-shaped curve is definitely in OCR textbooks. Yeah, cooperative binding might not be used. So it makes it easier for the second and third to bind. Very, very good. So what you want to say then is explain how changes in the shape of hemoglobin result in this shape. Basically, the first oxygen binds. I don't know what's a good way of saying it doesn't bind easily. First oxygen doesn't bind easily. There you go. That'll do. Easily. However, when bound, changes the shape. Okay, so as soon as it binds, it changes the shape, and basically what it does is it changes it in a way so that it sort of reveals the other binding sites. So, for instance, let's say that the first binding site isn't particularly available to be bound. As soon as the first oxygen does bind, all the other ones are sort of displayed in a magical, like, sort of way. So the first oxygen doesn't bind easily. However, when bound, it changes hemoglobin shape. Okay, you want to then say the binding, or sorry, this allows other oxygen molecules to bind more easily. Right? It should really bind easily to the last one. This graph, it shouldn't really look like this. It shouldn't look like that. It should look more like this, where it goes up and it just goes up. Because it is really easy for this last oxygen to bind. But the problem is, comes down to probability that the correct oxygen just struggles to hit the right place at the right time. So the reason it massively slows down between this point and this point is because 3 out of 4 oxygens are bound, and the last binding site is just unlikely to be struck or collide with the right oxygen molecule. So that's essentially what's going on. Anyway, so let's have a look then. Next question. Here's a good one for AQA. So figure 1 shows the oxyhemoglobin dissociation curve for 2 different species, A and B. Species B is more active than species A. Use figure 1 to explain how the hemoglobin of species B allows a greater level of activity. So let's have a look. So species B, if I draw just a random partial pressure line somewhere. So I'm going to draw a line on 7. Okay. So I've now got saturations of the 2 hemoglobins. So is cooperation relevant? Cooperation was relevant here. Sorry, I probably should have said this. This bit is called cooperative binding. That's just another word for it. Cooperative binding is where the final 3 oxygen molecules can bind more easily. Should have said that. Anyway, species B is more active than species A. Use figure 1 to explain how basically this graph is showing you this. Nothing to do with gradients. Affinity for oxygen is lower, so it's more capable to unload. Perfect. Right, so what you need to realize with these animal questions is if it's on the right, so let's say that species A is just a normal animal, right? Let's say this is a human. And let's say that species B is, I don't know, like a bat or something, right? Essentially, it is on the right. It's shifted to the right because at the same partial pressure, the saturation is reduced, which means species B has a lower affinity. Does that mean that it's better at loading, associating, or unloading, dissociating? Yeah, Educast do this too. Sorry. Good. This means that it is better at unloading, right? So species B has a lower affinity, which favors unloading. As I said earlier, it's always worth adding something in along the lines of, I know this because at the same partial pressure, the saturation of B is much lower. So at the same partial pressure, the saturation of B is much lower. Okay, that shows that it is favoring unloading. It is clearly, it's clearly got a low affinity. How do you pronounce Homo sapiens? Homo sapiens. I like that this comment is being hidden because it looks like you're being homophobic. I can see that you are obviously not. Anyway, so OCR don't need this, but they could ask you it. To get a final mark, what is this going to allow? So why does unloading, why is that a good thing if you are species B? What does it allow? Yeah, the curves do change from lungs to tissues. You are right. So this is showing you the lungs. Whoops. So the lungs are going to be up here somewhere. And the tissues are going to be here. Right? But if we compare two places of the tissues, so if I'm comparing the tissues here, wow, goodness. If I'm comparing the tissues here, I can see that the species B has unloaded a lot more than species A has. So species B is better at unloading, right? If I compare where the lungs are up here, I can see that the human is much better at loading than the bat. So yeah, you're right. So what am I doing? Good. So you guys saying it's going to allow oxygen for respiration. You're exactly right. So species B has a lower affinity. This favors unloading, and it means that the same partial pressure, the saturation of B is much lower than A, and this allows for oxygen to reach the cells for, and then specifically, do not say respiration, say aerobic respiration. Okay, so it allows oxygen to reach cells for aerobic respiration, or it might actually make sense if you said for more aerobic respiration or greater or something like that. I am willing to spend the whole hour doing it. I actually quite like teaching, so I guess that's probably why. Right, what I'm going to do is, this next question is an absolute, it's a horrible question, and this is one of the hardest questions I've ever seen on this. And I'm not going to go over it because I don't have time to, unfortunately, but I will tell you what the correct answer is. So the correct answer is, you're going to have to bear with me on this, is roughly 393.7 to about 437.4. So either of those two answers I would give. Okay. What I'm going to suggest is have a go at looking at this question in your own time, have a go at answering it, and if you can't, maybe I'll put it into a future web class, or you could do something that's going to really upset your teachers, and you could email them this question once you've had a go and say, oh, can you explain this? And I'll give your teachers some homework to do. Okay. So if you want to have a go at doing this, feel free to do it. That is the correct answer. See if you can work it out. It's a really tough question. I'd be intrigued to see if you could do it. Okay, right. Just like hemoglobin is, in fact, no. Let's reword that. When I think about hemoglobin, I think of it as this molecule which is adaptable because it can have a very high affinity in the lungs and it can have a very low affinity in the tissues. This means that it's capable of carrying out its job as effectively as possible, and it can basically do everything it wants to do. Now, Snap Revise, that's right. Snap Revise is very similar to that because it's adaptable. It allows you to become adaptable. It means that, say someone throws a tough question at you, bam, you can go straight into the tough question. Say someone gives you a nice, easy question, well, you will not overthink it. You'll go right into that slow question slowly, and you'll think, yeah, I know this. And you'll start writing down stuff, and you'll do really, really well. So, like hemoglobin being adaptable, Snap Revise is a tool, not in a bad way, is a tool to allow you to become adaptable too, so that you can do your absolute best, whether that's transporting oxygen around the body or learning stuff for exams. Sorry about that. I think I need some red wine if I'm going to carry on with these marketing campaigns where I basically try and make weird links between what I've taught that day and Snap Revise. So, for those of you that do not know very much about Snap Revise, I will tell you a little bit more because I don't just do these YouTube things. I do lots of teaching every day. So, for instance, let's say you do Edexcel biology because I've ignored them a bit today. For instance, at our very most basic package, what you can have is a whole load of videos and things like that which will help you to learn biology. So it's actually a bit more complex than that. It actually gives you a little quiz to see what you know, because every one of us knows that if you're going to revise effectively, you need to basically test yourself. And anyone who thinks differently to that has probably consistently done terribly in their exams. But as soon as you do start testing yourself, you end up working out what you do and don't know. So SNAP provides a sort of built where you have a quiz at the start and it will tell you what you do and don't know. It will tell you, therefore, what videos you need to watch and specifically what bits of the videos you need to watch so that you can actually start learning the things that you need to know. So, for instance, you might not know what a glycosidic bond is, right? So you could basically watch video and learn that. After you have done that, you'll get another quiz and it will hopefully show you that you now know a few things that perhaps you didn't know before. And after you've done that, it will give you an exam question where, if I can get it to actually work, there you go. This guy, whose name I don't know, will basically go through an exam question with you. So here is an exam question. Here is an answer. Come on. There it is. Here is an answer, like a model answer, and you can basically compare yourself to this guy and see how you're doing. Let's say that I don't get it still. Basically, there are tutors like me, just me, pretty much, on hand who can answer your questions. So if you don't get it, then I'll probably ask you a few questions and we'll sort of go through it and see if we can help you out. On top of that, there is also an exam pack where there will be loads of questions, like a ridiculous amount. And this is just one topic. This is like the first topic, right? And it might have a long question and then it has the solution to it so that you can actually get the right answers, right? Something really cool that we've done for this, and I've written some of these questions so I know it, is I've written it sort of as a student would write it. And I've made sure that I've added like additional guidelines every now and then, which is like me basically telling you what you need to do. So, you know how with mark schemes, they're quite difficult to understand and they have like lots of weird bold things and underlined things and all that nonsense. I've tried to ignore that and sort of write down exactly what I want you to say. So you need to state both 1,4 glycosidic bonds and 1,6 to attain the second mark. So I've tried to make it like that. On top of that, which is quite cool, and there are also like PDFs as well. Clearly this one doesn't have it for whatever reason, but we have like a revision guide as well, which you can have. We also have web classes. So like the very, very top tier package basically has more of me in it, which I'm sure all of you would absolutely love. Where basically I just go through various different like lessons and I do quite a few lessons every day. So I don't do them on Friday, but Monday through to Thursday I do. And just to prove it, look, here is that's today. Here's today. Here's yesterday. Here's the day before that. It's Thursday, Wednesday, Tuesday, Monday, Thursday. And they go back and I basically covered pretty much everything, right? So I think as of this week, I've just about finished teaching all of year 13. So if you wanted a lesson on pretty much everything, that pretty much exists now. I'm also teaching more stuff every week and I'm going through more and more. I'm also doing drop-in sessions where you guys can ask me literally random questions. So today, people didn't know stats very well, so I spent 2 hours going over statistics. That video is not online available. It's not available yet, but I promise you I did it. I did hemoglobin the other day. So here is me talking about hemoglobin with some nice people who were in my class. Don't know if it's going to work. I'm wearing a cap there. That's been my day. I was wearing a cap. There you go. Here is some stuff about hemoglobin. So essentially, SNAP provides a way where not only you can do like independent revision, which is something you definitely need to learn before you go to uni, but if you need the extra help, which I'm sure lots of people would like, then there are web classes and there are lots of other things that we offer on top of that too. In case that isn't enough, in case you're thinking, oh God, that sounds fantastic, but I just need a little bit more evidence that this guy isn't talking absolute nonsense every like week. I can show you more things that you can do. So if I haven't managed to sell this to you enough, which is totally cool, and I don't mind if that's the case, basically we've got loads of these like web classes still going on. So for instance, if you wanted to come to my next one, which apparently is the cardiac cycle and animal transport, then just turn up to that on the 18th of May, which is my dad's birthday, which is exciting. So you can set a reminder for that and you can turn up then and there. Otherwise, I have this discount code, which I was going to tell you about earlier. Voila. So you can get £10 off. And I'll just stick around for a bit if you guys have any other questions. So is there anything else that you guys want to know about? Like literally ask me whatever you want, apart from like weird questions, which I'm not going to know. Go on, what are you saying? I'm going to go back at the questions as well in case you said anything. Is it limited to one course or is it all of them? If you sign up to the course, it's limited to one. So if you sign up for biology, then it's biology, yeah. Oh, don't forget as well about this Instagram thing. Like genuinely, I've had very few of them come through so far. So the first week I did it, I think 4 people posted something. So there's a 1 in 4 chance of winning. So post something, post like you right now watching this, I'll wave or something, and you can do something, I don't know, good in the background or something, right? It won't let you sign up to Snap Provides. If it doesn't let you sign up, definitely if you email, not that, support@snapprovides.co.uk, you should be able to get through to someone. Well, you should. You'll get through to someone who will be able to help you out. Hemo10 is the code. Close. I'm going to start putting fake coupon codes, I think. Usually testing myself makes me realize how little I know. Yes, Freddie, totally right. Testing yourself is genuinely such a good means of learning. I can't emphasize enough how much you need to do that. So there's a big old educational theory which has been tested a lot recently, right? And it's basically suggesting that for you to learn something, if you read through a book, you are putting a bit of information into your brain, right? If you are doing, I don't know, you're in a lesson, things are going into your brain, right? The main thing that you need to do to revise is to extract it, right? You need to take it from your brain and you need to do something with it, like write down an answer or think about an answer or something, right? And it is this bit here which is fundamental in you learning. If you are just putting things in your brain but not trying to pull it out, when you end up going into an exam, that's essentially what you're trying to recreate. When you're in an exam, you're trying to pull out the information from your brain. But if you never practice, how are you going to do it? So as much as revising is important by reading and making notes and all that, if you're not pulling it out of your brain and trying to whatever the word is, if you're not trying to take it back out of your brain, you're never going to learn, right? And that's why teachers are so important, because teachers are these people who say like, oh, can you tell me about this? Or can you talk me through this, or can you do this? We're trying to get you to recall information. So this whole recalling of information is like as important as actually revising, and most people don't realize that. What else are you saying? Everyone else seems to know things. That does suck, but you'll get there. When sign up, is it limited on subject answer? That someone's already used your email address. I have a very easy solution to if someone's already used your email address. Use another email address. Like you must have at least 2, right? Everyone has 2. You have your spam email address that you don't use. Then you have the actual one for like serious things. So you must have at least another email address. If not, go onto Gmail and make an account. I used to have, you know, when like Netflix costs you like a few quid, but if you had like every month you get a free account. I used to have my normal email address, which I'm not going to tell you what it is, but let's just say something like Oli, right? I used to have Oli3one@gmail.com. Then I went for Oli32@gmail.com. Then Oli33, and it just went on and on until I had so many free accounts and stuff that it was genius. What else are we saying? What else? I somehow lost you. No, there you are. My whole life consists of skipping questions and going back and running out of time. That's okay. Skipping questions is fine. At least you can do the ones you know. But the more recall you do, the better you'll be. It's interesting when learning with a teacher. Philly, that's really nice. So there's something, there's a guy called Piaget who came up with something called the zone of proximal development. He was arguing that when you're learning, let's say that this is your knowledge, right? I don't know how many people are here. There's a good chance it's just me talking to myself at this stage. But if you want to move into the next bit, right? If you want to move into the next zone of knowledge, basically you need to have a learned other. You need someone who knows what they're talking about to help you get there, right? And that's called, it's like getting you into the zone of proximal development or something like that. But basically, yeah, having a teacher is a good thing, or not even a teacher. Having someone who knows it is good. What else? What school does Ollie teach at? Ollie used to teach at a school in Essex, but I no longer teach him a school in Essex anymore because I wanted to work for Snap Provides. Bloody hell, why am I wearing this? I'm doing drama. Bloody hell, why am I learning this? Yeah, my thick Essex accent might come through there. Can I ask you a question about something earlier quickly? Yeah, Toby, of course. If you're still here, I'm still here. Give me an example of phylogenetics. Phylogenetics. Why is that word not sticking in my head? Phylogeny. Oh, phylogenetics. Yeah, I know what phylogenetics is. It's when you have these trees, right? So how am I going to draw this? you have a tree like this, right? And then you've got all these things sticking out at the end of the tree. So all of these things are organisms that are related to each other. So this could be some fish up here. This could be like, I don't know, a toad. This could be like, I don't know, a dolphin. And then this could be you over here. Essentially, this is definitely entirely wrong as well, because I'm saying that the fish is more related to the toad. So I've actually done it the wrong way around. But essentially, phylogeny is a study of evolutionary relationships. So it's using things like DNA and amino acids in order to establish how closely related two organisms are. And when they share a common recent ancestor, which would be like here or here or here. And basically, the more related two organisms are, the more recently they diverged, and therefore the more common their recent ancestor is. Are these lessons good for A-level transition? So I've tried to make them sort of for like revision mostly, but yeah, I guess I'm implying that there's some knowledge. So I don't think it'd be bad for A-level transition, but I'm more going for revision. But it's kind of up to you, I guess. What else are we saying? Yeah, use fake email at gmail.com. Nice one. Just got emailed a lesson from your teacher. Nice. When hydrogens bind to hemoglobin to form hemoglobinic acid, what actually happens to the hemoglobinic acid? Does it dissociate into something else eventually? Yeah, I think so. I don't actually know, Toby, off the top of my head. It's not going to stay like it forever, though. So yeah, it will just ultimately change back. Yeah, 5. Are you by yourself or do you have company? Do I have company right now? I am actually by myself. I do sometimes have company, but I don't right now. I learned Piaget at GCSE psychology before Corona stopped you going from school. Oh, Piaget's cool. I like him. In fact, I don't actually agree with him entirely, but he's interesting. Anyone else? I think that's about it. What do we do if we have a private account, Ollie? What do you mean? What board do I teach? Why is that question come up? Well, I teach all of them. All the British ones, anyway. What do you think is the worst topic in A-level biology? All of A-level biology is fascinating, so I disagree. Right, Valor's like that's about everyone done, I reckon. There's only 29 people here now, so I reckon that's time to go. Right, have a really nice rest of your day. Briefly define taxonomy. Unknown. Not even please. Just briefly define it. Just briefly define taxonomy. Do I teach drama? I do not teach drama. I finished it in year 9. Taxonomy is like putting organisms into groups, right? So it's kind of, well, classification, I guess, is. So you have taxonomic groups, which is what classification puts things into. So the taxonomic hierarchy, for instance, is domains, kingdoms, phylums, all them. Anyway, right, I'm going to head off. Have a lovely afternoon, guys. Enjoy the rest of your week, and I will see you again at some point on Monday. Don't forget, yeah, do this screenshot thing. I want to see these funny, well, not funny necessarily. I want to see something creative, right? I'm a scientist, but I like creativity. So send me a nice creative Instagram story and maybe you'll win an account. Who knows? Right, see you later, guys. I will catch you later. Bye.